So we can start by reducing the fractions that are reducible. So looking at number 7, that could turn into a 1 and 4, because 4 goes into 4 one time, and 4 fits into 4 16 times. 1/4 as a decimal is 0.25. You can think of it as a quarter is worth 25 cents. We can multiply by 5 to turn this into 100. And 3 times 5 is 15. So 15 hundredths is 0.15. You can use 1/4 to help you figure out what 3/4 is. You could double 5 to get a 10 and then use the tenths place. A group of 4 friends have a lemonade sale. They earn 23 $1 bills as profit from the sale. Can they distribute the money so that each friend gets the same amount of money? If so, how? Well, we can split 20 into 4 parts. That would give each of them $5. But then we would have 3 extra dollar bills to split up into 4 parts. If we split $3 into 4 parts, each person would get 3/4 of a dollar, which is 75 cents. 3/4 is 75 cents. So each person would get $5.75. Here I have the long division process for the problem 612 divided by 8. In the previous lesson, we would have rewritten this remaining part as a fraction 4/8 based on what we divide by. Another person could have written this as 76.5. Do these mean the same thing? Well, 4 is half of 8, and a half can be written as 0.5. If we were to continue this long division process, we could write a decimal in this position, and after the decimal point, we can continue to add zeros. 8 fits into 40 exactly 5 times, so these are equivalent to each other. In this problem, we would have 2/8, so we could write it as 76 and 2/8 like we were in the previous lesson, or we can put the decimal with an extra 0. Make sure your decimal is lined up in your long division problem, and bring it down. 8 fits into 20 twice, giving us 16. 20 minus 16 is 4. And we can bring down another 0. 8 fits into 40 exactly 5 times. So this could also be rewritten as 76.25. So for this problem in your book, we are going to add those decimals in, bring down a 0. 8 fits into 30 3 times, which is 24. If we subtract, we would get 6. 8 fits into 60 7 times, which leaves us with 4. Bring down another 0. 8 times 5 is 40. So this is 76.375. Now there are a few different ways that we can round this answer. If we're talking about money, we use 2 decimal places, so we would round. The 5 makes the 7 go up. If we were rounding to the tenths place, the 7 would make the 3 go up. And if we're rounding to the nearest whole number, or to the ones, the 3 is below a 5, so it stays, kind of just gets chopped off the end. If this 3 was a 5 or more, we would raise that to a 7. But anything that is less than 5, it just gets left. All right, so divide and express the quotient as a decimal. So the 2046 goes inside, and the 16 goes on the outside. Remember, it's very important that we think about, does 16 fit into 2? No. Does it fit into 20? Yes, 1 time. That gives us a 4. Now bring down the 4. Make sure you're keeping your place values organized. 16 times 2 is 32. 4 minus 2 is 2. 4 minus 3 is 1. Bring down that 6. If we write out our multiples of 16, it looks like we can fit it 1, 2, 3, 4, 5, 6, 7 times. There's an invisible 0 here. It can fit into 148 times. That would fit into 127 times. And into 85 times. $127.875. Divide, round your answer to the nearest tenth. So if we're going to the tenths, we have to look at the hundredths to tell us whether or not to round up or leave it. Does 7 fit, or does 9 fit into 7? No. How about into 70? 9 times 7 is 63. 10 minus 3 is 7. 6 minus 6 is 0. Bring down another 0. 9 fits into 70 7 times, giving us 63. The hundredths, is 7 higher than a 5? Yes, so that rounds the tenths place up, 2 and 8. This decimal would keep going, but we can stop at the hundredths because we use the hundredths place to round the tenths place. This time we are rounding to the hundredths, so we need to go to at least the thousandths to tell us whether to keep it or to round up. So we have 117. That would be 234. If I add a 7, that would give me an 11. 351. 468. 585. So I believe that's 1, 2, 3, 4, 5 of them can fit in. 6 minus 5 is 1. 12 minus 8 is 4. Then we're going to use a 0. It can fit into 410 3 times, which is 351. 10 minus 1 is 9. 10 minus 5 is 5. Bring down another 0. It can fit in 5 times. That will leave us with 5. It can't fit into 50, but we're at the thousands, so we can stop there. And we are rounding it to the hundreds place. So does the 0 tell the 5 to go up or stay? Since 0 is less than 5, it's going to stay. Riley divides 11,586 by 24 as shown. She concludes that the quotient is 482.18. Why is Riley's quotient of 482.18 incorrect? Well, this would be 482 and 18/24, which is not equivalent to 482 and 18/100, which is what we have here. 18/100 can be written as 0.18, but 18/24 cannot be rewritten as 0.18. Then it says find the correct quotient expressed as a decimal. So we're going to continue after the decimal point by bringing down a 0. 24 into 180. No, 52. 72. 96. 120. 144. 168. This would be 1, 2, 3, 4, 5, 6, 7 of them. 10 minus 8 is 2. 7 minus 6 is 1. We'll bring down another 0 and it fits into 120. 1, 2, 3, 4, 5 times. So this would say 482, 0.75, not 0.18. During his Major League Baseball career, Hank Aaron played for the Milwaukee Braves and the Atlanta Braves. Hank Aaron's first year playing for the Milwaukee Braves was in 1954. In 1954, he got 131 hits and 468 at-bats. Hank Aaron's first year playing for the Atlanta Braves was 1966. In 1966, he got 168 hits in 603 at-bats. A player's batting average is calculated by dividing the number of hits by the number of at-bats. Batting averages are expressed in thousands. In which year did Hank Aaron have a higher batting average? Divide to 3 places after the decimal point. So we are going to have 2 different division problems. 131 divided by 468 and 168 divided by 603. Well, we know 468 does not fit into 131. So let's start there. Now we have 1,310. I'm going to create a list of multiples of 468 to help guide my work from here. So we will have the first one is 468. The second one is 936. Then we would have 1,404. So it looks like only 2 of them are going to fit. We'll borrow here. 10 minus 6 is 4. We'll need to borrow again. 10 minus 3 is 7. Now I have 12 minus 9 is 3. Bring down a 0. Looks like we're going to need to continue our multiples here. All right, so we can fit 1, 2, 3, 4, 5, 6, 7 times. Ten minus 6 is 4. 13 minus 7 is 6. 6 minus 2 is 4. Bring down another 0. That would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Ten minus 2 is 8. 3 minus 1 is 2. 6 minus 2 is 4. But it said we needed to go through 3 decimal places. 603 does not fit into 168. We're going to keep our 603 multiples going. So it looks like it can fit into 1,682 times. Ten minus 6 is 4. 7 minus 0 is 7. 6 minus 2 is 4. Bring down a 0. Would be 1, 2, 3, 4, 5, 6, 7 of them. 10 minus 1 is 9. 3 minus 2 is 1. 7 minus 2 is 5. That would be 1, 2, 3, 4, 5, 6, 7, 8. Ooh. Ten minus 4 is 6. 8 minus 2 is 6. 11 minus 8 is 3. The question was, in which year did he have a higher batting average? 0.279 is greater than 0.278. And that first one occurred in 1954. So in the year 1954, Hank's batting average was higher. Make sure your warm-up and your lesson are finished for today.